Hey everyone. So today we're going to cover access specifiers. We're going to talk about comments again and the importance of it. We're going to talk a little bit about vectors, and then we're going to do a house activity. So the first part of it is access specifiers. So there are various different ways to set the scope of who is allowed to access your public or your member functions. There's public, private, protected, and friend. So we've seen public and private, and that's pretty much what we're going to be using exclusively in this class. But in future classes, you might touch protected and friend. The idea of friendship is actually, let me start at the top. Public, anyone can access it. It's public. So if you had a variable that was public, then anyone outside or inside your class could access it and change it, which you don't necessarily want to have happen, because maybe they could change the variable that makes your class not stable. Maybe you were always expecting a number, the value of the number to always be positive. If somebody goes and changes it to be negative, and that breaks your program in some way. Private is things that are only going to be accessible within the class or with a friendship. And so essentially, for private in this class, we're going to use that for all of our variables or any of our helper methods or helper member functions. So maybe you have something that does some work that's going to be called by a public member function. That would be private. If you never intend on something being called or changed directly by main, then stick it in the private area just to be safe. And so private allows privates are able to be changed by things that are public. So maybe you have a public setter or getter inside the class, and they're able to go in and change or access the private parts, but because it lives inside the class. If you're outside the class, you can't access the private parts of the class. And so the friendship, which you'll deal with next semester towards the end, friendship allows a friended class to go in and modify the private. And I'm going to just skip over the protected access specifier because you're not going to be using that this semester. So documentation is super important at every stage of programming. Even when you don't feel that it's necessary at that moment, what happens over time is that we forget. We forget what we were doing. Many times that I've picked up a project a few months, 3 months later, or maybe a year later, and I had no idea what I was doing, or maybe I left it in this incomplete state. And so because I didn't leave comments, or because I left comments, actually, I was able to pick up where I left off. If I didn't leave comments, then I would have been totally lost, and I probably would have to start over, because I don't know. I'm not confident that I've finished something or not. So comments can be really, really useful to you, the developer, if you're just resuming a project on your own. Or if you're picking up a project from somebody else and they've left really good comments. I mean, I've dealt with projects that somebody left really good comments, and it was great because there was an issue, there was a problem, and within a matter of 3 minutes or so, this multi-thousand line file, I was able to go exactly where the problem was happening and was able to fix it because somebody left really good comments. I've also worked on projects that had really bad comments, and even after several weeks of working on something, I wasn't able to resolve the problem because I just couldn't figure out what they were doing. And I had to hand off the project to somebody else because I didn't have enough time to deal with it. So documentation is really important because even if you don't ever intend on working on that same code again, somebody else might. Your project whatever you might code might be picked up by somebody. And telling yourself, oh, I'll just comment when it's important later, that's not a good mentality to hold. You should start working on good practices now, because your actions right now will become behaviors later, and then they'll sort of become these values of things that you just naturally do, and you won't need to think about it as much. So it's really important that you start doing the good things early so that you get used to it, so that you're accustomed to it. And so there's another phenomenon called code rot, and code rot is real. Code rot is essentially over time your code degrades. And I'm not talking about the individual bits, how your program is stored. I'm talking about what the world around your code, while your code may maintain integrity with itself, with the individual bits itself, the world around it is changing. The C++ language changes. The libraries that you're using, the ways that we're able to access files and read in input and write to the screen, all of that is always changing. And what can happen is that over time those changes become so significant that your code no longer works, or no longer works properly, which is a really bad state to be in, where the code used to work and just from an update the code stops working. And so code rot is a phenomenon that over time your code is going to degrade to the point where it might not do what you expect it to do, or it just might not work at all. And so by leaving lots of comments, that can be really useful, because maybe you know that something's going to happen. I've personally left in comments saying, this piece, I know, like in this version of this library or language, it works this way. In future versions, it's going to work this way. And literally, somebody just opening up my program, in 10 years from now, all they need to do is comment out that line or delete that line, and then comment back in a line that I had commented out saying this is how it's going to work in the future, because I was reading, because I had read the new documentation of how something would be implemented, and so I was able to write useful comments to whoever, 10 years from now, when my code stops working properly, somebody can just, the code is all written. They just have to remove the inline comment, and then bam, they're in business again. So so the downtime of the application would only be a matter of minutes once somebody was assigned to actually fix it. And that a reminder that we have two forms of comments. We have the inline comment. So typically this would be a whole line, or at the end of the line talking about what that line is doing, versus a block comment, which can be multiple lines. And the reason you would have a block comment is maybe you wanted to talk about the author, the versions, things that the class did in a generalized form, so people could get acclimated to what's going on, or where you needed a lot of lines to explain what was actually happening in your code. And then we have these cool little flags that we have, like @author of the class. Yeah. So what's inside of the parens is when you would use them. So for the author tag, you'd only use it at the top of the file. So like the class, the top of the class file. I think I have them down here. Yeah, here we go. So a block comment would look something like this. So you have your author, that you would use that flag only with classes, or at the top of a file if the file had no classes. Parameters, so we would use this in methods and or member functions and constructors. So you wouldn't expect a parameter to a class because a class doesn't have any parameters, but a class's constructors and methods do. So you'd have this parameter there. And then return, we would have that in methods or member functions. And then C is if for example you were given an algorithm to implement or whatnot, you would put a link to that PDF or the Wikipedia page or whatever in this C. And so C is essentially maybe this is the standard that I'm implementing, or maybe this was I use this resource to help me write this code. So I use C heavily when I'm working on a very complicated project and I want to cite a lot of people's sources, like, hey, this person helped me, like I was reading this article somewhere and it was really useful, and in order for you to help you understand what my code's doing, you should see this thing. So C's are a way of citing your sources, which can give you credibility, because it means that however you implemented your code, even if you did it wrong, that you had a particular intention, and that it was somebody externally from you that had that idea. Also, if you have a C for an algorithm and you made a mistake in that algorithm, somebody can just go to the C tag and then go to that website, look at it, and then look at your code and know whether or not you've implemented it properly or not. So it can be useful for helping people understand what your code is doing, but it also can help you get credibility, because what you're coming up with this function or member function or whatnot, wherever the C tag might belong, wherever that tag belongs, people can look at it and say, oh, he's looking at somebody else's stuff, and unless that person was also wrong, then both of them probably have it right. So it gives you a little bit of credibility. So here's an example of the file that I've pretty much used at the beginning, throughout the semester. I have the file called blank CPP, and it's what I copy whenever I'm doing an example. This is what I copy from to start off. And so you see I have all of these crazy tags. And really there should be, this name should have like an @author and an @email and whatnot. But this is useful because an instructor, or really anybody, opening up your file can get acclimated pretty good. Like they can look at this, and actually this email is different now. They can look at this and then they can contact the person if something's wrong. They know the file name, and so maybe somebody renamed the file and that's why everything broke. They can look at the file name and then look at the actual file name, the file name tag here and the file name up there, and be like, oh, those don't match. It's also useful if for some reason somebody's printing out or displaying your code. This helps give them an idea of what they're looking at, because maybe they didn't print out or aren't displaying the file name. And then an example name. So in this case, I have examples. So this might be an assignment name or project name, and that also helps get people to know the area around them. And then a description of what are we doing inside of this whole program, inside of this whole file, what's going on. Code status. So does the code work? Is it completed? Is it missing things? And then we have our does the program compile? So it's always good to keep it in a state that it compiles, but if for some reason it's not, if it doesn't compile and it has errors and warnings, maybe doing a little description of what those warnings are is going to be very useful, because now if somebody picks up your code or if somebody's grading your code, they can look at it and go, oh, well, something's missing, and the person knows exactly what was missing. And then any additional comments. Let me pause the recording.